Hello and welcome to another exam paper walkthrough. Today we're looking at the Edexcel half paper series and today we're looking at set 5A and this is going to be paper 3, which is the calculator paper. I'm going to be using my old emulator, the FX82. Very little difference between that and the more modern ones if you're using those. Okay, it's a 45-minute paper and we will start off. I will try and do a question and then mark it rather than a page at a time. So question 1, write down all stages of your working and find the gradient of the straight line. So finding the gradient of the straight line, you pick two nice points to work with. Pen's not working. So pick two nice points to start with. I mean, by nice points, I mean ones that are actual coordinates. And then realistically, you didn't even need to do one coordinate, take away the other. This goes up by 3 and this goes across by 2. So the gradient is going to be 3 over 2. Which would be absolutely fine for the answer, or 1.5. In terms of marks for that question, then it picked off one method for finding the gradient, so just a method mark followed by an answer mark, so M1 and an A1. For the second question, biggest mistake on this was there were a number of people that have put -0.5, I think because they used a negative coordinate to try and help themselves work it out. So a couple of people have got a -1.5. The frequency polygon, generally speaking, the biggest misconception for this is getting it confused with a cumulative frequency graph where you plot it at the endpoints. For a frequency polygon, you plot them at the midpoints. So you plot them at the midpoints. So my first coordinate should have been at 5, 6. Second coordinate at 15, 9. Third coordinate at 25, 8. 35, 7. And then finally 45, 5. And then we join them up with a straight edge. I'm just going to grab a straight edge. So join them up with a straight edge, not a curve. For frequency polygon, I don't tend to join it to 0, 0 unless the question gives you a value of a frequency of 0. But technically, there's nothing wrong with joining it to 0, 0 because we're talking about length of time and you can't have 0 length of time, really. But I don't tend to, for a frequency polygon, join 0, 0 up. But it's not incorrect if you have. Let me just check the mark scheme. B2 for correct. Plotting of 5 points and joining them with a line segment. So it is B2, 2 marks for that. Although if you've not got a completed one, I was allowed to do 1 mark if you'd plotted all the points at the end, which is where most people got marks, or if you plotted them all correctly but didn't join them up. Okay, question 3 then. So we've got, generally speaking, this wasn't terribly done. How much does Kalinda pay for each unit of electricity? A few people didn't spot that it was after for each unit. So let me just look for the first 60 minutes. The reason that it said the 60 minutes is if you actually look, the gradient changes after 60 minutes. So, which did pick up a few misconceptions on the second part. So we're looking at, over this time period of 60 units, £15 was used. So for each unit, we're looking at 15 divided by 60, which is 1/4. And this is in pounds and this is in pence. So £1/4 of a pound is 25 pence. For part B, we're told she could use tariff B instead. Here is the monthly charge for tariff B. Kalinda uses 90 units of electricity. So if I look at how much that would cost from tariff A, which is what the graph is, for 90 minutes, if I go up and then read across, I'm looking at, you can kind of see the line, that would be £19. For tariff B, we're just using the formula 20 pence of unit for each unit used. So 90 times by 0.2 to do it in pounds, which would give me £18. So which one should you use? Tariff B. Or it says, should Kalinda change to tariff B? Yes, as £18 is less than £19. I tend to finish it with that because I know that from experience, the mark scheme will be, I can pick up all marks from that line there at the moment because it will be something like the two prices and then the correct conclusion. So yeah, so the mark scheme states an M1 for showing 1,800 or £18. So that's my M1. My M2 is for the price for tariff B, which can be read off the graph. And then a C1 for, is it C1? Yeah, C1. And it says C1 for 18 and 19 with the word yes. So in effect, that line gives me all three bits that I need because I've got 19, 18 and yes in that same line. So it makes it really straightforward for your market if you state your reason and state the two comparable figures. Okay, question 4, simplify. So when we're multiplying, when we're dividing powers by each other, we subtract the indices. So we're just doing q to the power 3. For the second one, for part B, it was quite the biggest mistake here. Lots of people got the W and the Y right, but they didn't get the number part right. So if I do W to the power 2 to the power half, we times them, so it would just become W or W to the 1. Y to the 6 times by a half becomes Y to the 3. And then the number part, the half means the square root, so the square root of 9 would be 3. For part C, not that it overly matters, but that piece of information is quite crucial to this because if x is less than 1, it can create some issues in terms of ordering. The smallest one here, well, anything to the power 0 would be 1. So if I put that one in the middle for now, so that would have a value of 1. Then I'd just compare it to the number 1. The smallest value here is going to be this one, x to the minus 2, because that would become 1 over the value squared. So that would be my smallest value. My next smallest value is going to be x to the power half, which would be it would be x to the 0. Then we've got x to the power half, which would be the same as x to the power 0.5. Then it's just x, then it's x squared, if I've got those in the right order. Just flicking through my mark scheme. Yeah, that's the right order. And again, I awarded it's 2 marks for them all correct in the correct order, I think. If I do the whole question rather than just part C. Part A was B1 mark for just q to the power 3. The second one was 2 marks if you've got the correct answer only. And then in effect, if you've got 2 of the parts correct but 1 part incorrect, you got 1 mark. And then for the final one, it was 2 marks if you got them all correct. And then B1 for any 4 in the correct order. So if you've got 1 out of order, you could pick up 1 mark on that. For question 5, I'll do the quick version of this. In a sale, the normal prices are reduced by by 1.5. So if we've got a 15% reduction, it means that would be 0.85 as a decimal multiplier. So if the value times by 0.85 is equal to 479, then the normal price would be 578 divided by the multiplier instead of times by the multiplier. And when we do that, I'll do it on a calculator, but 578 divided by 0.85, and it gave us quite a nice answer, 680. And then the 3 marks awarded for this were, if you picked out the multiplier, so the multiplier here, that would have been 1 mark. So it's like an M1 mark for that, an M1 mark for the division, and then an A1 mark for the answer for the 3 marks. For question 6, this is the one I'd worked with my class with quite a bit prior to the exam, and most people got at least one of the marks. So the first mark was for squaring both sides. So y squared would be equal to 2x plus 1 divided by x minus 1. My next step is to get rid of the x minus 1 as the denominator on this side. To do that, I would times by x minus 1 on both sides. So that would give me y squared times by x minus 1 is equal to 2x plus 1. If I then multiply out the bracket, that would give me y squared x minus y squared is equal to 2x plus 1. Then if I take all my x's over to the left-hand side and everything else over to the right-hand side, that would give me y squared x plus minus 2x is equal to y squared plus 1. Then I needed to factorize by taking x out as a common factor. So x times by y squared minus 2 is equal to y squared plus 1. Then I divide by y squared minus 2 on both sides. And that gives me x is equal to y squared plus 1 divided by y squared minus 2. 1 second. Okay, and the marks for this question were pretty straightforward. M1 for squaring both sides to get the correct equation, so it's an M1 for the first step of squaring both sides. It was then an M1 for removing the denominator to get the correct equation, so M1 there. It was then M1 for correctly gathering x's on one side with the non-x's on the other, so M1 there. And then that leads to an A1 for the final correct answer. So that's the 4 marks for that. Okay, question 7. Question 7. So triangle P is reflected in the line x is equal to minus 1. So the line x is equal to minus 1 is that line there. So if we do that step and reflect it in there, that would give us that as our reflection. Does it tell us to label that? And then if I label that, it doesn't say to label it anything. And it then says, then reflected in the line y is equal to 1. The line y is equal to 1 would be that line there. So if we reflect in that line as well, that gives us that as our new shape. So we've gone through 2 transformations to get there. So that's our new shape. To describe how to get from P to Q, you can see that it's been rotated 180 degrees, and then that gives you the real hint about the point of rotation. So it's rotation of 180 degrees. You don't need to specify clockwise or anti-clockwise because 180 would be the same either way, and then it's about the point. The combination of the 2 mirror lines gives you minus 1, 1. And then the marks for that was I quite like these in terms of markers. It's 1 mark for rotation, 1 mark for 180 degrees, although I could accept half a turn, and then 1 mark for the point. So that's just 3 marks. Right, question 8. So question 8. So I misread this when I first did it. I didn't pick out the word inversely. So f is inversely proportional to the square of x. So if I set that up in terms of mathematical language, so that reads f is inversely proportional, because that's 1 over x squared. So we can then bring up a general equation. So x is equal to k over x squared. And then we substitute in the two values to find the value for k. So when f is 0.5, x is 5. So 5 squared is 25. Then when we rearrange that, we get 0.5 times by 25 gives you 20. So 20 is equal to k, which gives you your value for k. So your actual equation would be f is equal to 20 over x squared. For the second part, work out the positive value. I'll discuss the positive and negative near the end of the question. So we basically saying f is equal to 320, which is 20 divided by x squared. So if I rearrange that by timesing through by x squared and then dividing through by 320, x squared is equal to 20 divided by 320. And cancel down by a 0 and simplify the fraction. X squared is equal to 1 over 16. And if you square root that, you get a plus or minus. So I'll write it once with a plus or minus. So plus or minus, square root of 1 is 1, square root of 16 is 4. The question only asks for the positive value though, so we're only after the quarter value. And marks for that question were, it was an M1 for, an M1 for, I would have called it processing mark, but no major drama. M1 for the general equation, f is equal to k over x squared. M1 for substitution, so an M1 there, and then an A1 for the formula. And then likewise on the other side, an M1 for the method, and then an A1 for the answer. Okay, for the capture recapture question, I tend to do these as two fractions, although I do quite like the ratio table method as well. But it's just kind of old habit because from doing quite a bit of A level. So the fraction of bees caught compared to the complete population is x out of 50. So in effect, x is standing for the whole population. Realistically speaking, you would probably have the fraction the other way around, but because I'm rearranging it, I tend to put the larger value on top. And then if that's going to be equal to the proportion caught the second time. So 40 bees were caught and 8 had the die on. So those two fractions must be the same. So all I then do is times through by 50. So x is going to be equal to 40 times 50 divided by 8, which is the same as if I cancel by, I can actually cancel by 8 here. So that goes into that 5 times, and 5 times 50 is 250. The second one, write down any assumption that you have made. The assumption that you've made is the proportion caught on both days are equal. That's the assumption that I've made. There are reasons behind why that might not be the case, but the assumption I've made is that the proportions caught on both days are equal. Proportions caught on both days. You can often get away with an explanation about that. You could say something like, you've made the assumption that the dye hasn't rubbed off any bees. You've made the assumption that no bees have escaped from the beehive. Those are kind of reasons why, but the assumption you've made is that the proportion caught on day 1 is equal to the proportion caught on day 2. And then marks for that were, it was an M1 for setting up a fraction of proportion, M1 for working it through, and then an A1 for 250. And just kind of scanning, if you hadn't have crossed out your working, you can pick up marks. Yes, only cross out working that you're positive is not going to be useful, even if you can't go any further. And then, did I do all the marks for that? Yeah, sorry. The assumption was a B1 mark. It states, for mathematical assumption, e.g. fixed proportion, on the mark scheme. So, yeah. For question 10 then, write as a single fraction in its simplest form, 2 over x minus 4 minus 1 over x plus 3. Well, we need to put both fractions over the same denominator, which is going to be found by multiplying them together. So I will often combine them straight away. You can write them as 2 separate things, but it means you've got to write the denominator twice, which I found a bit of a pain. To do that, I would need to times this fraction by x plus 3. So I'd have 2 lots of x plus 3. And then the other fraction, the numerator, would need to be times by x minus 4. So x minus 4. And then you've got a double negative that you've got to watch out for. But when we tidy that up, 2x minus x would be x. 6 minus minus 4 becomes 6 plus 4. So it would be 6 plus 10 over that denominator of x minus 4 times by x plus 3. Okay, and marks for that were, if you've got them over a common denominator, so that's the common denominator, you picked up a method mark. If you've multiplied out the brackets, M14, it's really that line there, and then an A1 for simplifying. So I've not written on the answer line, but that's fine. Then the final question, no, not the final question. Yes, the final question. Question 11, solve the inequality. So for this question, my first step is to multiply out the bracket. So if I multiply out the bracket, x times by 2x would give me 2x squared. X times by 3 would give me 3x. And that has to be greater than 20. To solve a quadratic, realistically, whether you're solving via the formula, via complete the square, or via factorising, you need all of your unknowns on one side and it having 0 on the other side. So if I minus 20 from both sides, I'll get 2x squared plus 3x minus 20 has to be greater than 0. I'm going to ignore the greater than 0 for now, and I'll bring it back in a moment, and I'm just going to try and factorise that. And I'm going to put it equal to 0, but I'll come back to that in a moment. So if I'm trying to factorise it, to make 2x squared, I must have a 2x and an x. And then I'm looking for two numbers that multiply together to make minus 20. But because of this 2 lots of one of the numbers plus the other number add together to make 3. So if you think about factors of 20, you've got 2 and 10, which I can't put in a combination to make that work. One of them's got to be negative. I could have 4 and 5, and that would work. So if I had 4 minus 5, so 2 times 4 would be 8, minus 5 would be 3. So I'm looking at 4 and minus 5, and the 4 needs to go in the bracket opposite the 2, so 4 there and minus 5 there. That gives you 2 values for x. Either to make, that one's the easier one, to make that bracket 0, x would need to be equal to minus 4. To make that bracket 0, x would need to be equal to 5 over 2 or 2.5. From that stage, that's nearly all of that's 3 of my 4 marks. But from that stage, any quadratic, well, any positive quadratic will form that shape. And if I was putting it as a graph, it would cross the x-axis at these 2 points, one at -4 and one at 2.5. So in effect, that would be a very rough sketch of my graph. And the bits of my graph I'm after, and this is where I bring back the inequality, are where the graph is greater than 0. So where the graph is greater than 0 is this section here and this section here. And they're two separate inequalities. So I need to say that x would need to be less than -4, or when x is greater than 2.5. And that's the final step that is designed to try and catch you out on that question. Marks for that come from, it is M1 for rearranging. So if you get to this stage here, that's an M1. If you find a method to solve, that's your second. Okay, a method for solving, which is kind of, this was our method by factorizing. An A1 for finding the two values, no, sorry, an M1 for finding those two values. But then it's an A1 for getting the inequalities right. Okay, so that's the paper. I thought that was a fairly decent paper in terms of difficulty. There wasn't actually that much calculator use on it. A lot of it worked out fairly nicely without a calculator. If I go to the mark scheme, just to bring up this final page, so all of those questions were linked to those topics. So if, for example, you struggled particularly on question 8 as a topic area was direct and inverse proportion. So that can be useful for targeting your revision in the future. Thank you very much for your time. I will stop the video there. And if you have any questions or comments, feel free to type them in the chat, and I will see you soon.